Okay, Newton's second law of motion. Force equals mass times acceleration. Okay. Basically, what Newton was saying, he said that acceleration of an object will increase with increased force, and it will decrease, so acceleration will decrease with an increased mass. All right? He also states in this law that acceleration will accelerate in the same direction as the force. Okay? So just a few things about Newton's second law. First of all, Newton's second law says that force equals mass times acceleration. So we could put that into a formula triangle of mass times acceleration equals force. Force is measured in units called newtons, mass measured in kilograms, and acceleration in meters per second squared. Okay, so force is measured in what we call newtons. Okay, and a newton is equal to a kilogram times a meter per second squared. So Newton's second law states force equals mass times acceleration. Based on that formula, you can say that the acceleration of an object will increase with increased force applied to it. Increase as you increase the force applied to the object. Okay? Based on that formula, you can also say that acceleration of an object will decrease as you increase the mass of the object. Okay? And he also states that the acceleration will occur in the same direction as the force. Of the force applied. Okay? So what is he saying? To keep it brief, look, if you have an empty shopping cart and you push that shopping cart, it will move. If you push that empty shopping cart twice as hard, it's going to move twice as fast. Now, if you add groceries to that shopping cart and you double its mass, and you push it with the same force that you pushed the empty shopping cart, it will decrease its acceleration. So acceleration will decrease because it will not be as fast because it's twice as massive. It's got much more mass. It's got double the mass, so its acceleration rate will be cut in half. Okay? In both scenarios, the acceleration of the shopping cart is going to occur in the same direction as the force you apply to it. Okay? So if we're using this cart, let's say we say you apply 400 newtons of force to a 200 kilogram 200 kilogram shopping cart. Okay, its acceleration would be 400 newtons divided by, we plug it into the formula, right? 400 newtons divided by 200 kilograms. Okay. You would end up with 2 meters per second squared. If you double the force, and you made it 800 newtons, and it was still an empty shopping cart, it would be 800 newtons divided by 200 kilograms, and that would be 4 meters per second squared. So you can see you doubled the acceleration because you doubled the force. Okay? If you kept the force the same, and instead of 800 newtons, you kept it at 400 newtons and doubled the mass, so you made it 400 kilograms, you would have 400 newtons divided by 400 kilograms. You would have 1 meter per second squared. So you would halve the acceleration if you double the mass. Here, you double the acceleration because you doubled the force. Okay? And in both cases, the acceleration of the shopping cart is moving in the direction that you push it. Okay? If you have any questions about this, please feel free to come ask us. There'll be a couple more videos that discuss how force affects the acceleration of an object and how mass affects the acceleration of an object. Okay, so keep an eye out for those. If you have any questions, if you're not clear on this, please watch those. It should clear anything up. If not, please come see us. See you tomorrow.